speaking, neuroscience is a scientific study of the human nervous system, encompassing the brain and spinal cord as well as the nerves that connect them to the rest of the body, investigating the structure, function, development and evolution of the nervous system, and how it relates to behaviour and cognition. In the context of the science of education, neuroscience explores the biological processes of the brain to understand how learning occurs and how to improve educational practices. Also referred to as neuroeducation, it explores the brain's mechanisms involved in different facets of learning, such as reading, numerical understanding, attention and learning challenges like dyslexia and ADHD. By gaining insight into how the brain processes and acquires knowledge, educators can design more effective teaching methods and foster environments that enhance learning outcomes. Neuroscience in children has highlighted the importance of engaging learning materials and experiences that stimulate the brain. During most children's early years, the brain grows rapidly, with 90% of brain development happening by the age of 5. This development shapes how children learn and react to the world around them, with early experiences having significant effects, determining pathways that can influence emotional regulation skills and cognitive abilities. Educators can harness these developments by providing positive experiences that promote healthy neurological development, with activities that enhance emotional regulation and cognitive skills, such as sensory play and language exposure. Age and stage refers to the idea that children's brains develop over time in somewhat predictable patterns, and that their ability to learn, focus and regulate emotions change as they grow. However, this approach should be treated purely as a guide, as it often ignores natural variation in cognitive, emotional and social development. This approach can also contribute to fixed mindsets and about ability, potentially affecting self-esteem and expectations. For example, it is well documented that those born in the summer months often fall outside the average curve due to nothing more than their date of birth, as can be seen on this chart. This is when the importance of a teacher knowing their students comes to the forefront, and many educational establishments are favouring personal learning paths and scaffolding to better support and encourage their students. The concrete operational stage, the third stage in Piaget's theory of cognitive development, typically occurs between the ages of 7 and 11. Logical thinking begins to start, so neuroscientists recommend hands-on learning opportunities and visual aids help to encourage this, with children benefiting from structured yet flexible learning. This can be achieved in the classroom with topics such as volcanoes and the exploration of solids, liquids and gas. The amygdala, involved in emotion, works closely with the memory system, which is why students remember how they felt more than what was said. Emotional arousal can also boost memory encoding, especially when the emotion is closely linked to the learned material, which suggests that our brains tend to prioritise and better remember emotionally significant events or information, prioritising emotionally important information, surprising information, or that which is relevant to survival or goals, as explored by Kessinger in 2009. For example, novelty and uncertainty stimulate dopamine release, which enhances memory encoding. This can be achieved in the classroom with provocative questions, amusing rhymes or myth-busting facts. One of the digraphs taught is poo at the zoo, and without fail the children giggle at it, but most importantly, they remember it. Unexpected activities such as mystery boxes are another way to release dopamine with students, similar to the Bush Tucker trials on I'm a Celebrity. Between the ages of 12 and 18, the prefrontal cortex, responsible for planning, impulse control and reasoning, continues to mature, so these students benefit from critical thinking, debate and self-reflection, with extra guidance and emotional regulation and decision-making due to the increase in risk-taking behaviour within this group. However, a mismatch at any age can actually hinder learning. If educational demands are too high for a child's brain stage, it can lead to frustration, behaviour issues or disengagement. Likewise, underestimating what older students can handle may lead to boredom or lack of challenge. At its core, learning is the process of changing the brain based on experiences. When we learn something new, our brain creates or strengthens connections between neurons called neuroplasticity, and every learner is capable of development with the right support. Understanding neuroplasticity helps encourage a growth mindset, promoting resilience and perseverance. Neuroplasticity also provides hope and strategy for children with learning difficulties and those needing to relearn or catch up, as with repetition and the right input, new pathways can be formed to compensate or strengthen weaker areas. However, neuroplasticity is experience dependent, meaning that positive emotions and safe environments make learning more effective, whereas stress and fear block new learning by engaging the survival brain. By teaching children that their brain keeps changing, it builds confidence and curiosity, fosters self-awareness and self-regulation, and reinforces the idea that learning never stops, even into adulthood. Prior to the 2nd of July, I didn't even know how to make a video. Neuroscience has shown us that memory isn't one thing, it's a process with stages. Encoding, taking information through attention and perception. Storage, keeping that information in the brain over time. And retrieval, bringing the information back when needed. Attention span and working memory are related but distinct cognitive functions. Attention span refers to the ability to focus on a task or stimulus for a period of time, while working memory is the system for temporarily holding and manipulating information. However, suitable strategies for both do exist. Low-stakes recall activities such as mini-quizzes help to refresh working memory and refocus attention by reorientating wandering focus. Attention and attention span are foundational for learning, particularly in early years and primary settings. Memory is central to learning, and neuroscience provides insight in how the brain encodes, stores, and retrieves information. Working memory, for example, is where new information is temporarily held and processed, with around 10 to 20 seconds being the optimum length. Therefore, it is easy to overload students' working memory. One way of combating this is with chunking, thereby breaking down complex informational tasks into smaller, easier to digest chunks. Not only can this method be used across the ages, but also across subjects too. Neuroscience also discovered that multisensory input improves retention, so by combining visual, auditory and kinesthetic activities, the learning modalities proposed by Barb, more information is likely to be remembered by students. To store information long term, the brain rehearses it, connects it to prior knowledge, and uses emotion and meaning to make it stick. One method is repetition, which is considered to be an excellent tool for learning, and always has been, although now, through neuroscience, there is evidence to back this idea. The use of repetition can be seen in the national curriculum with the use of topics, which results in the same information being given, but in different formats and styles. Due to the current tight curriculum, repetition doesn't happen as much with older students in the arts, but can be seen especially with younger students, such as a rivers topic, encompassing visiting a river, making a river outside, drawing a river, countries with well-known rivers, and even the science behind rivers. Asking students to self-reference with content is another excellent strategy for building emotional connections to content alongside empathy-driven learning, which deepens understanding. For example, when studying the Holocaust, students can write a diary as if they were alive, discussing their daily activities, what they have eaten and how they are feeling, or a day in the life of a guide dog. Students can discuss what a guide dog does, watch educational videos of guide dogs at work, write diaries as a guide dog, discussing what they see and how they feel, and even act as guide dogs for their peers, which would also release dopamine to aid memory encoding. Metacognition, thinking about thinking, is an important aspect of neuroeducation, helping students become independent, reflective learners who can plan, evaluate, and adapt their learning. Metacognition relies mainly on the functions controlled by the prefrontal cortex, such as planning, decision-making, self-monitoring, error detection, and goal setting. Although metacognitive skills in young students are emerging, they can be taught and strengthened over time with support. Reflective journals are an excellent way to achieve this, encouraging students to think about what was a success and what they would do differently next time. With younger students, metacognition can be strengthened with think-alouds when modelling a task, writing a sentence on the board with mistakes and discussing what needs to be rechecked and correcting. Today's learning strategies are increasingly informed by robust scientific research, making them more effective and targeted than ever before. This is particularly important in the context of special educational needs, where developments in neuroscience and cognitive science have enhanced our understanding of various conditions. As a result, we are now better equipped to adapt our teaching approaches to meet the diverse needs of our students. For example, neuroscience has found that students with ADHD often benefit from structured routines, tasks being broken into chunks, and movement being incorporated into the lessons, alongside frequent feedback and, when possible, tailoring to individuals' interests, increasing engagement and dopamine. Whereas students with epilepsy often benefit from visual schedules, clear transitions, and structured days to reduce stress on their frontal lobe, alongside tasks being chunked, relaxation exercises, and short breaks. With all neurological disorders in children, emotional and social well-being needs need to be monitored, with anxiety, depression, or stigma can worsen cognitive symptoms, impacting focus, engagement, and memory. Recent neuroscience research confirms that play is a powerful driver of learning, especially in early and primary education. Play activates multiple areas of the brain, particularly those linked to emotion, executive function, and memory consolidation. Learning through play encourages neuroplasticity, with the executive functions of attention, self-regulation, impulse control, and working memory being improved too. Play can be in many forms, such as role play to engage the prefrontal cortex, constructive play to stimulate the parietal lobe, and motor cortex or physical play to activate cerebellum and basal ganglia. Unfortunately, as when any neuroscience findings are taken too far, neuromyths arise. Some of the more common ones are shown here. So, for example, eating sugary snacks results in hyperactivity and reduced focus and attention. As far back as the 1970s, many researchers believed that sugary foods and food additives were linked to cognitive defects, especially in school-aged children. These results were only fueled by parents and teachers consistently reporting that children are less attentive and more active after consuming sugar. This study shows that 57% of UK teachers agree. However, it has been debunked several times by researchers. Studies have also shown that proper hydration can improve memory, critical thinking skills, and overall cognitive function. While this is true, it ignores many other factors that influence attention, like sleep, nutrition, mental health, learning environment, and teaching style, treating water as a magic fix. By exploring the dynamic connection between neuroscience and education, we gain a richer understanding of how children learn. Insights into memory, attention, emotion, and brain development empower us to teach in ways that are not only more effective, but also more compassionate and responsive. Still, teaching is as much an art as it is a science. The real impact happens when educators bring cognitive science to life through creative, engaging, and emotionally meaningful learning experiences. This is especially apparent with additional needs, where neuroeducation helps educators not only recognise neurological differences and avoid misinterpreting behaviours, but also adjust their teaching practices to be more inclusive and accessible, focusing on strengths to encourage confidence and individuality. When we teach in ways that match how the brain learns best, we do more than help children succeed. We spark their curiosity, grow their confidence, and help them enjoy learning for life. This is where brain science and great teaching come together to make a real difference.